Now let us see the effect of negative feedback on the system. Most of the control systems use negative feedback because of its advantages. The various advantages of a negative feedback are: the feedback reduces the time constant of a system. This indicates that the system becomes more fast due to feedback, which improves its time response. The overall gain of a system reduces due to feedback, and thus by controlling the feedback, the gain of a system can be controlled as per the requirement. The feedback controls the dynamics of the system, and by adjusting the locations of its closed loop poles, thus the stability of the system, which depends on the locations of the closed loop poles, can be controlled by using feedback. The feedback increases the bandwidth, that is, the frequency range over which the system performance is satisfactory. The feedback reduces the effects of the disturbances occurring the forward path, the backward path, as well as the output. The feedback reduces the sensitivity of the control systems as to the parameter variations. Now let us see the requirements of good control system. We have around 7 to 8 requirements which is actually necessary for a good control system, primarily being the accuracy, sensitivity, external disturbances or noises, stability, bandwidth, speed and oscillations. A good control system must be highly accurate. It should operate with as little error as possible. The open loop systems are generally less accurate, and hence feedback is deliberately introduced to reduce the error in the system, which such closed loop system requires a design so that the steady state error tends to zero. Sensitivity requires often play an important role in the design of control systems. All physical elements have properties that change with environment and age at the parameters of control systems cannot be considered to be constant over the entire operating life of the system. That is, the winding resistance of a motor changes with respect to a time, and a good control system should be very insensitive to such parameter variations but sensitive to the input commands. It requires that its performance should not be affected by small changes in the certain parameter of the systems. Now let us see the external disturbance or noise. All the physical systems are subjected to external disturbances and noise signals, and during operation, brush and commutator noise is in motors. Thermal noise, voltage and electronic circuits are good examples of noise which affect on wind. On performance of antenna is good example of for external disturbance. A requirement of a good control system is that the considerations given should be given at the time of designing so that the time system is insensitive to noise and external disturbances but sensitive to the input commands. It should be able to reduce the effects of the considerable disturbances. Now let us see what is the requirement of how does the stability plays a role during the requirements of a control system. A system concepts of stability means the output of system which must follow the reference input and must produce bounded output or bounded input. However, due to wrong selection of parameters, it is possible that the output tends to increase without bounds. This is called as unstable condition. A good control system is one which is stable in nature. And let us see how the bandwidth plays an important role during the requirements of a control system. This requirement is related to the frequency response of the system. For the input frequency range, it should give satisfactory output. The frequency range for which the output is satisfactory is its bandwidth. The satisfactory output means the maximum possible output without overshoots and maximum possible output without overshoots, and it should not be changed with the input frequency is given range. Speed. A system should be have good speed. This means the output of the system should approach to its desired value as quickly as possible. This is measured in terms of its rise time and settling time. System should settle down to its final value as quickly as possible. Oscillations. The system should exhibit suitable damping, that is, the controlled output should follow the changes of the reference input without unduly large oscillations or overshoots. So, in general, a good control system should be accurate, reliable, stable, fast, responding, insensitive to parameter variations and disturbances, but sensitive to change in the input.